Hello, everyone. This is Torkel Patterson. I'm the Vice Chairman of the International High-Speed Rail Association, and I'm very happy to be here. And it's very appropriate that we have this HSR panel for the Global Railway Review because we're truly global today. I'm here this evening in Tokyo, and we have our friends and Mr. Kumar coming from India and then moving around the globe. We have Taiwan, John Chen, and we also have Mark Thurston, of course, with HS2. And later we'll have Rick Harnish joining us, and we'll be thrilled to have this full-on discussion. Before I start, I just want to make a comment about the Global Railway Review team that's been helping us do this, because this is the first time that I've ever seen such a magnificent undertaking worldwide. And we're learning a lot from you by watching this, how you're doing it. And I really tip my hat to the courage of Craig Waters and Bonsri and Tony Cornell to pull this off. And I'm so glad that so many of you are here with us today. International high-speed rail has been an interesting, over the globe, we've been sharing a lot with everyone. And we noticed that there's so much progress being made everywhere. Although because of the costs involved and the legacy issues and the time it takes to do these, a lot of people sort of think, well, it's really not ready for prime time yet. But we like to think of the fact that we're not talking about solutions that are solutions for transportation. We're talking about solutions that are for transformation. And we firmly believe that the projects that we're going to talk to you about here will lead to transformation. And so how do you account for transformation? How do you promote that? When the Japanese built their first bullet train, they said the cost was too high. And the president of Japan National Railways at the time fudged the cost to get it through the diet, and then announced the real cost and then resigned. And look what we have today. We have a magnificent railroad structure because everybody thought it was too expensive to build. But because the World Bank had given a small loan, that was the hook that allowed the government to say, we have to pay that loan back, and they built it. So there's a lot of creative ways that go into these high-speed rail, but the net effect of it all is truly transformative projects. And so we're going to hear about those today. And I'd like to start with the CEO of High Speed Rail 2, Mark Thurston. Mark, would you like to begin for us?
Yeah, of course. Thank you, Torkel. I'm just going to share my screen. I've got a few slides to talk to here today. If they come up on full screen. There we go. Let me just go back there. Let's get to the beginning. There we go. Okay. Well, good morning, all. Thank you, Torkel, for that introduction. As it says on the screen there, my name is Mark Thurston. I'm the Chief Executive Officer of HS2 Limited, which is a government company sponsored by the Department for Transport here in the UK. And our job is to really sponsor, specify, design, and then oversee the build of HS2. HS2, I'm sure this audience is aware of, but in summary, it's 550 kilometers of railway that will connect Birmingham in the Midlands, in the middle of the country, to London in the south, and to Leeds and Manchester in the north. The first phase of that, we're now underway. We have legal permission. It's a 10-year program from now that's recently been reset by the government, supported by the government. It's a £45 billion investment. It's going to take us 10 years to build this first phase, and then the subsequent phases from Birmingham, what we call the western leg, to Manchester, and then from Birmingham to Leeds, the eastern leg. So effectively creates a Y-shaped network, which when it's fully built over the next 20 years or so, will effectively become the sort of backbone of the rail network here in the UK. So I'm just going to click through a few slides. Getting Britain to work, what does that mean? Well, of course, HS2 as a big construction project is very much at the heart of helping government and helping the country get back on its feet post as we work our way through COVID-19. We've done a lot of work in HS2 with our supply chain in finding a way of keeping our operatives safe. in a way of making sure that our work is safe in its interaction with local communities. As you will know, building railways is quite disruptive. A lot of what we're doing is in urban and quite dense areas. And then we've got sort of the contrast of quite sort of rural areas of construction. So we've gone to great lengths working with government guidelines to make sure that we keep people safe. And that goes everything from the way we deal with deliveries onto site, encouraging our workers to bring their own lunches so we don't use the canteens. And we're pleased to say that we've now got some 220 plus sites along the route, fully open, and some 9,000 people now working on HS2 right across the UK, and some 2,000 companies. So HS2 is very much a sort of an economic enterprise, and there's obviously a lot more to come there. The key decision the government made earlier this year was to get our main civils contracts awarded. We had been doing lots of enabling works, which is utility diversions, lots of excavations. We've got a number of big archaeology program, a lot of ecology work, as you know, to sort of prepare the site. But we've now proceeded with the main civils contracts, 4 major contracts, a £12 billion investment, and that would those contracts alone will generate sort of thousands of more contract opportunities here in the UK. And we think that at peak, we're probably going to need somewhere around 30,000 people working right across the UK to help build HS2. So, we've worked through a difficult period, as many of our colleagues in the construction sector have here in the UK. But we've got good momentum now as we go into the second half of the year. Building better, building bolder. What do I mean by this? Well, it's clear from what I've said that and the UK's, like many advanced economies around the world now, sort of trying to work its way back out of the impacts of COVID-19. And our Prime Minister has talked about building back better, building bolder, and HS2 is clearly right at the heart of that. I mean, the reality is we've not built a railway north of London in the UK in living memory. The Victorians were the last people to build an intercity railway here. So we're into uncharted territory, but very much HS2 is right at the heart of the economic recovery. And certainly we've been encouraged by government to sort of move as fast as we can to keep people in work, and obviously not just those directly involved in designing and building the railway, but of course those sort of tiers of suppliers who support that. So this is very much an important part of the economic recovery of the UK. And of course, I'll come on to, so what do we see as the benefits of HS2? But what these images here try to do is just give you a sort of sense of some of the works that are going on. Our first tunneling machines, I'll come back to, they arrive early next year. But why does Britain need HS2? And what's what we call the strategic case for HS2? And we say it's what we call our 3 Cs. So this is about capacity, this is about connectivity between our major cities, and cutting carbon. I'm going to touch on all of those for a few minutes, if I may. So at full capacity, when the full network is running, we think there's going to be probably somewhere around 300,000 people a day using this system. That provides massive capacity onto our existing network. And when we've looked at sort of capacity modelling for the national rail network in the UK, and we have 3 existing northwest lines, the only way to really build capacity into those systems is to build a new line. Clearly, to try and enhance existing railways is very expensive, very disruptive. So all the economics show that we really need to build a new line. And that's really what HS2 will do. And recognizing that these railways were built by the Victorians, they've served us very well. But as an advanced economy, one of the few economies in the world that doesn't have sort of a high-speed rail system that connects its major cities. So that's an important part of what we're about at HS2. Firstly, is capacity, and of course, I've already touched on the sort of economic regeneration of the project in the near term. But of course, longer term, when you look at the sort of connectivity between major cities, that's what drives growth, that's what drives investment, that's what drives prosperity. And we have a real disparity in sort of economic performance in the UK between London and the southeast and the rest of the country. The Midlands and the North continue to lag behind other major cities around Europe because of their poor connectivity. So HS2 is an integral part of creating a much more balanced economy. You may have heard our Prime Minister and our government talk about levelling up our country, and we see HS2 as an important part of that levelling up economic agenda. But of course, HS2 is not a standalone project. it becomes an integral part of our network. We connect the new railway to the existing railway, and we'll move significant traffic off of the existing railway for high speed onto the new railway, which I say gives us massive capacity onto existing lines, whether that's both for passenger or for freight traffic. And then finally, carbon. And HS2 will definitely play its part in the government's ambition to be net zero by 2050. And I just want to spend a few minutes talking a little bit about more this sort of carbon agenda. I mean, you can read the slide, but just a few stats to sort of put this slide into context. In 2017, so only 3 years ago, transport in this country passed energy as the biggest generation of carbon. So transport is now the biggest generator of carbon emissions, and road traffic in particular was 91% of that. So that's a huge amount of carbon that we're generating in the UK. And if you think about the transfer of, and rail by comparison will only end up being about 1% of the country's carbon emissions. So as we can build this railway and we move people out of their cars, out of lorries, onto the railway, and we get people out of domestic air travel onto the railway, HS2 is an integral part of driving this ambition for net zero in the UK. And I think we've seen in other countries, I mean, I know in Italy, in Japan, in France, Spain, where countries have connected their major cities with high-speed railways, they've seen this modal shift and they've seen domestic air travel reduced between their major cities. So as people start making longer journeys between these cities, HS2's got a really important part to play there. Just to sort of dwell on the road traffic for a second there. We estimate that HS2 will reduce car travel by 1.2 million tons of carbon dioxide every year. So that's equivalent to 18 million litres of petrol not being used in this country once we start operating this railway. And this is a railway that we expect to be a highly efficient, using low carbon energy. So when it's fully complete, this will be without doubt a major contributor to our low carbon future. But I just want to put the carbon into perspective, because the other sort of challenge that comes back, of course, is, well, we use a hell of a lot of carbon in building this railway. It's going to consume a lot of concrete, and I just want to dwell on that for a second. So we're looking at how we can reduce carbon use in construction, and to put it into context, all of the carbon we'll generate, as the slide says there, to build the first phase is the equivalent of 1 month's road transport emissions in the whole of the UK road network. So yes, we will generate carbon in construction. It needs to be put into perspective, but we are looking at ways of how we can reduce carbon both in the design and in the construction, and I'll talk about a couple of those in a minute. I talked earlier about building boldly. This is a picture of Interchange Station, but I want to talk about a couple of other examples. Old Oak Common, which is one of our stations in the south. Our designers have looked at the roof canopy and have reduced the design and the build of the roof canopy by over 1,000 tons of steel. So huge saving both clearly in cost, but also carbon. This is a picture of Interchange Station, which is one of our stations in the Midlands. We go for planning consent for this station later this year, and it's already received what we call BREEAM, which is the sort of regulatory framework for buildings for environmental performance in the UK. When this is complete, this station building will be in the top 1% of sort of eco-friendly buildings in the UK. It's using air source heat pumps, solar panels, rainwater capture, electric vehicle charging points, a whole area of sort of biodiversity around the station. So this is sort of, again, giving you an example of how we're going to build boldly and put the way we build HS2 very much at the heart of our sort of carbon future here in the UK. And then just to pick on some of the ways we're building, using new technologies. So this here little picture is the first electric forklift truck used in the UK. Has the ability to save around 400 litres of fuel a week by being electric based. We're putting this into use, and we're seeing a lot more appetite in our supply chain for using electric and autonomous vehicles as a much sort of smarter, cleaner, safer way of building this railway. Equally, we've adopted some industrial design techniques from sort of aviation and car manufacturing, for some of our major civil structures, and we're taking up to 20% of the mass of steel and concrete out of those structures in their design. But our focus now is all on delivery. Here's a sort of short map that sort of shows the railway. So phase one here, bottom left on the screen, that's where I've talked about the main civils contracts. The tunneling, the first 3 tunneling machines arrive next year. So we start tunneling in April. Through this year into next year, we start all the procurement for the railway systems. We hope to award, if not later this year, early next, the contract for the rolling stock. And of course, the other big sort of challenge for us on phase one in building the railway is community engagement. You know, thousands of people who did not choose to live or work or go to school or have their businesses next to this railway. We have a big endeavour to sort of work with those people impacted by our work. And that's been very challenging, as you can imagine, under lockdown, where we've stopped sort of face-to-face engagement events, but nevertheless, we've put technology to good use to really help us there. On the right-hand side on this slide, phase 2A and B, so there are sections from Birmingham further north. They've got to go through the legislation process. There's more work to be done there, but nevertheless, that's the second phase in the second 10 years of the 20-year programme that I talked about by way of introduction. So I think just to maybe conclude, Torquil, if I can, I've talked about how HS2 is a national endeavour. It's going to consume huge amount of resources from our construction sector for the next few years. It provides unprecedented capacity on our rail network. The connectivity between those major cities is an integral part of that levelling up agenda I referred to, that the government are so crucial, is so key to their sort of manifesto. And clearly, the sort of carbon credentials of high-speed rail are well understood, and we see that making an important contribution to the country's ambition for carbon neutrality in 2050. So a little bit about HS2. It's a major sort of national undertaking, and of course, what we'll leave, whether it's in skills, whether it's in transport, whether it's in carbon, we'll leave a sort of profound legacy, which we're already very aware of as we start to build this railway. So I'll stop there, Torquil. I'll stop sharing my screen and perhaps go back to you for any questions.
Thank you, Mark. We do have a few questions, actually. But before we do that, I just want to say I'm really impressed with what you showed about your commitment to decarbonization. Everybody knows in general about railways are more efficient, but the fact that you can have something you can show the public, like that forklift truck, that's relatable to the person, they can really see your commitment to it. And also your prevention measures that you have in effect for COVID are quite impressive, and I'm sure that one of the questions is, has that slowed down your timeline at all? But I'll just combine the second question with that, and that is thinking about the COVID situation and the future of high-speed rail. Do you see any long-term effect of this on the future of high-speed rail, or do you see it as this will be something we're over and we'll be back to where the public was before?
Well, I think we all are wondering what the future looks like, and I think we all aspire to perhaps get back to a world that we understood. I'm in our Birmingham office today. There's only a few dozen of us here, and I'm keen, when it's safe to do so, to get people back to the office. I'm convinced that we won't be able to build this railway successfully from our homes, as much as we've actually operated like this for 4 months very effectively. Our contractors on site have worked very effectively. I think in terms of the longer term impacts on high-speed rail, I mean, we're going to take 10 years to build this railway. So the world will be a very different place in 10 years from now. And the reality is, whether it's with distancing or without distancing, in the peak, our major interconnecting railways between our major cities are at capacity. And as I said in my introduction, the only way we're going to unlock that is with a new railway. So I think the strategic case still stands. Clearly, time will tell exactly what transport use looks like in all countries, frankly, post sort of the worst of the pandemic. I think it's fair to say in the UK, and I don't think we're alone, that domestic aviation has come under significant challenges in particular. And I think if people want to continue to get around the country as they will, then particularly if they want to get around fast and they want to be conscious of their sort of carbon credentials, to my point, the only way you can do that is with rail. So I think for me, high-speed rail is almost as relevant now as it ever was, as the UK, like many economies, work their way out the other side of COVID-19.
Thank you, Mark. I completely agree with you. And also, I think the impact of being able to spread the population centers out in between is one of the advantages of high-speed rail. And as people are looking for more luxurious or comfortable places to work from home, maybe that'll, I don't see any long-term net minus on that. Thank you very much, Mark. I know you've got to run off to something, and I really appreciate you taking your time to be with us today, and wish you the best in this great program. And I hope to see you in London soon.
Yeah, thank you, Tokyo. Thanks very much. Bye-bye.
Bye. Thank you. Our next speaker is John Chen. He's a senior advisor to Taiwan High Speed Rail, who just retired as the chief operating officer. And John has watched the development of the Taiwan High Speed Rail from the beginning, and it's quite a success story. It's amazing, actually. And it connects two very viable city pairs between Kaohsiung and Taipei. And the ridership is great. And the professionalism and the technology that they apply to the project is world-class. And they consistently rank as the most favorite service provider in Taiwan. And they're a very difficult audience in Taiwan. So it's really high marks that they receive all the way around. And so I'm sure we're going to enjoy this. And Mark and John, up to you.
Okay, thank you, Toko, your introduction. I'm going to share the Taiwan High Speed Rail, the experience and the future. Growth. So I'm going to cover, which will be covered in my presentation. And firstly, for the sorry, let me open up the presentation. Okay. And previously, I was in charge of the operation and maintenance of Taiwan High Speed Rail, but just like Toko just say, I just retired on 15th of this month. And currently, I work as a senior advisor, still assist our president for the operation and maintenance and other engineering and engineering and construction stuff. Okay, firstly, I'll introduce the performance of Taiwan High Speed Rail. Taiwan High Speed Rail, actually, we have total length is 350 kilometers. And you can see in this chart that Taiwan is a small island, that the population mostly condensed, concentrated on the western part of this island, and which occupy 93% of total population, especially for the three major metropolitan area, including the most north city, Taipei, in the middle is Taichung, in the most south cities, the Kaohsiung. And we opened to the public of the season from the 2007, that's January 5th. And total length is 350 kilometers. So we have currently 12 stations, although the government's planning to have extension from the north toward the north or toward the south. And we have a maintenance depot, five depots, and currently we have 34 transits in the fleet. And weekly train service will provide 1,016. And the revenue operation time is from around 6 o'clock to the midnight, and the rest of the maintenance work time. And in the bottom of this chart, you can see this. We have a 7 stopping pattern. Like I just said, we have 34 transit in all total fleets. So how can we use up all these 34 transit? So we provide 7 stopping patterns. But actually, because like I just said, that we have 3 main cities in the north, in the middle, and in the south. So we provide the maximum number is pattern D, which cover these 3 metropolitan area. So and the rest of them is not so, comparing with not so many services. And this is the ridership. So we have more than 13 years of operation. The first year, 2007, we have only 43,000 ridership per day. And last year, we have 184,000 per day. As you can see, the second year after the opening to the public, we have almost double of the ridership. So this is actually, I think it is a fact for a lot of system, I mean high-speed rail system open to the public, going to share almost very similar experience. And then after the second year, the ridership will increase gradually. And for the other performance record, we have still, I mean, maintained zero train accident rates. And for service reliability, which exclude the disaster, which is 99.97%. And the punctuality within 5 minutes is 99.64%. The average delay after this more than 13 years of operation, we have average delay only 12 seconds per train per service, actually. I'm going to introduce several of the innovative achievements. To provide a good service, better service to our passengers, we try our best so that if you take a high-speed train, I think the passenger would rather have a more quiet space. So when the train master validate, the passenger occupy in the seat, normally previously, 5 or 6 years ago, we have to check to ask the passenger to show his ticket to validate. But with this system of this app, Smith, we call that Smith, we can validate this seat information without disturbing the passengers, which update from time to time through the wireless transmission. So this is a very helpful app. And we provided our experience to use this kind of app, this kind of tool, like with our Japan, the other railway company. Okay, also we have another app. Actually, we provide a series of apps, so the passenger can use his smartphone, can get a lot of available information to help him to take the high-speed train of Taiwan. So like a TX Express, just showed this kind of app, which provide the passenger can buy the ticket through the smartphones with different channel. And also we consolidate, integrate with other public transportation means, and also with Google Maps. So passenger can get real-time information, so that it will be very convenient for them if you want to, after they arrive in the destination station, they can take very easily to find the good connecting means for him to transfer to other cities, especially in Taiwan high-speed rail. The station normally will take 15 minutes from the center of the city to our station. So to provide a very convenient connection transportation means is very important. And also this app provide other promotion information, and also some the sightseeing points or gourmet recommendations. So passenger can use this kind of only one single app, can find all the necessary information for connecting, for eating, or for traveling, those kind of stuff. And also we provide other convenience store. For example, if one passenger can buy a ticket with his personal smartphone, he can also distribute it to other smartphone, like his children or his friend, those kind of stuff. So to be very convenient. And also we provide multiple ticketing channels so that the passenger can buy the ticket through like a convenience store. In Taiwan, convenience store is very popular. It's very easy to find one, just like in the corner, like 2 or 3 minutes away from your home. It's very convenient. And also you can use mobile phone to buy ticket, and which download the QR code in your mobile phone, so you can enter the ticket barrier very quickly. And then other electronic ticket joint card or mobile payment, those kind of stuff. So we do our best to help a passenger can easily buy a ticket, so that he will not think it's not, it's not easy, because the high-speed rail train ticket normally is more expensive than compared with conventional rail. So to provide us a convenient as possible is very important for passenger. And then we also trying to get some value-added product to our passenger, like we have we call the value package, so that we integrated like we call the high-speed rail holidays. So we jointly with some hotel, which we think is very good, good quality. So we want to integrate this kind of service. So passenger not only he can take high-speed rail train, he can also to the some city to find the good hotels or good restaurant, those kind of stuff. And of course, if you want to have the self-arranged kind of tour, also there's provide a series of flexible this kind of package. And for group tour or for overseas travelers, so all this kind of means is very helpful for the passenger around in Taiwan or even in other country. Okay, then I mentioned something about the COVID-19, which in Taiwan. But as you can see, comparing with other countries in the world, Taiwan has much less confirmed cases so far. We have the first case occurred at the end of January, although you can see we are very close to China. So but we are lucky because we have very less confirmed cases. So, but we still, because other country very close to our country still have a lot of booming cases. So we set up a kind of response team, not only in our company but in the whole country. So we daily we have a daily meeting in the country, but in our company we have 3 times a week to check to see if there's a new cases going to happen or what we can do. But we still have very serious impact through this COVID-19. For example, in the month of April, we have only half of the ridership compared with last year, same period. So we still suffering this kind of profit loss as well. You can see this chart. Okay. And then we take a series of measures against COVID-19. For example, we periodically clean and disinfection of station and trains, and we request that our passenger have to wear mask. And when he take the high-speed train, if he doesn't have a mask, then we ask him, you have to come back to find another face mask so that you can come back. And we measure the body temperature. If the body temperature is higher than 37.5 centigrade, then he or she is not allowed to enter our station. For those kind of very serious measure taken. Okay, and then I'll cover a little bit about the future challenges. You can see that we are almost 15 years. Normally speaking, for any kind of E&M devices or facility, actually 15 years is very normally it's a very important critical year. That means a lot of your device, E&M device, is going to replacement. Okay, and the maintenance work is going to more and more. So, but we realized that once we already decided, the system, to select the system, there's normally it's very rare. It's a little room you can change another system. So to be a sustainable development, you have to have well maintained of your system. And of course, periodically, you have to upgrade and replace of this system. So the life cycle cost is very, very important. To construct a system, a new system, is easy, but to maintain, to make it during the whole life cycle in very stable, in very reliable system provide to the passenger is also very important. And then I said about the operator and the manufacturer's loads. Like us, for the train operator, we maintain the system periodically, and we are facing in the issue of system upgrade and replacement. So every country have different laws and environment to operate it, so that you have to meet these kind of constraints. And to keep the system reliable and stable, of course, everybody have to face this kind of thing. And the cost increase, of course, especially you have to replace and upgrade. This is a bigger cost, especially for high-speed train. Even it's a new system, when you replace, it's already the upgrade is even more expensive than you buy in the first time. So the financial feasibility is very important. And as a system manufacturer, like our the Japanese manufacturer, we needed them to provide us suitable solutions with reasonable prices and to help us some technical assistance because software and hardware need to upgrade. You need the original manufacturer to help us like operator so that you can operate in good condition. And also that the price again is always the very important factor. And then I think that the operator and the manufacturer, we should build up a kind of good and long-term relationship so that the operator can be to achieve a sustainable cooperation with manufacturer. And the to continuing operation. So we the challenge we are facing and the effort we are making, like we have to renew and upgrade our code system with reasonable prices. Of course, to reduce the cost, to control the cost, we need to contact the OEM, or even we find some good local manufacturer so that he can manufacture locally. This is all these kind of things to need to do to control the cost. So also that we have to try to build the local railway industry so that it can help us and we can work together to control the cost. And of course, we are lucky because we choose the Japanese Shinkansen high-speed rail system. It's a very reliable system. So we are glad. So we are honored too, so that we can be very successful because of we are adopting this Japanese system. But also that we have to increase the service capacity, and we have to renew and upgrade the system. So we need to find a way to balance the the cost, and also those challenges. So we are hoping that the record, we have very good performance record. We want to maintain that record. So we try to cooperate with the manufacturer, the Japanese manufacturer. So to achieve this goal, we hope that doesn't matter the operator, the manufacturer also need to work together, to cooperate each other, so that we can be continue successful in the future. Okay, that's my presentation to share Taiwan high-speed rail's experience. Thank you very much.
Thank you, John, very much. And for those of you who haven't been to Taiwan and haven't ridden on it, I really encourage you to do so. It's a really great system. And what Taiwan has accomplished, both technology-wise, maintenance-wise, and its ability to attract and keep customers. And the numbers of customers they had, just for reference, they have more riders than the Tohoku Shinkansen in Japan, than the Niigata Shinkansen, than some of the other lines too. So pretty soon they'll be the second busiest. They'll be second only to Japan Central Railroad in their volume of passengers that they carry. They also exceed Kyushu. So congratulations to you, John. Well done. And I'd like to ask the audience to please hold your questions and start sending them in. And when we finish and have our wrap-up session, then we'll take those questions and go through them and bring them up with our panelists. Next, I'm very pleased to introduce Sandeep Kumar, and he's with the NCR-HSL, which is the High Speed Rail Authority of India. And this line is between Mumbai and Ahmedabad. And I've been to Mumbai many times, but I've never been to Ahmedabad. And when I did, I was so impressed. It's a very busy corridor, and it's the heart of the diamond trade in India. Many people frequently going back and forth, frequent, very efficient conventional line service, and relatively flat the whole way. It's going to be it's a great location for India's first high-speed rail corridor. So with that, I'd like to turn it over to Sandeep. Sandeep?
Good morning, everybody. Good morning to eastern part of the globe. I think good afternoon to central part, and still good morning to London and beyond. Okay, I'll share my screen. I think it's visible. The screen is visible. Hello, can you hear me? I'm audible.
Yes, it's visible.
Yeah,
Very
yeah, no
good.
problem, Sandy.
Okay. Thank you so much. This Mumbai Ahmedabad is the first bullet train project, high-speed rail project in India. And we have one common thing with the Taiwan. We have also adopted the Shinkansen technology for this, the first project, because of their reliability and safety parameters. So my presentation will cover 5 aspects. First is the project overview, then the present project status, then benefits and challenges, and also what does future hold for us. The first is our project overview and salient features. So this project is basically, we call it Mumbai Ahmedabad. Basically, it is a Mumbai Sabarmati. Ahmedabad and Sabarmati is a twin city type of thing. It's only a 8-kilometer difference. So it's a Mumbai Sabarmati project, and this is the first project. And the majority is in the Gujarat, state of the Gujarat. And I mean, there are 3 districts of Maharashtra and 8 districts of the Gujarat. It starts from the Mumbai, and Mumbai is the only underground station. Then we have got total 12 stations. All are elevated. Baroda is the main station, Surat is the main station, and Ahmedabad is the main station. So we have got both type of services, and end is Sabarmati. The total length is 508 kilometer. And this we are having mostly on the viaduct. 90%, roughly 460 kilometer is on the viaduct. Then 9 kilometer is the bridges and tunnels. Our longest tunnel is 21 kilometer with 7 kilometer under sea. We are coming out of Mumbai through tunnel only up to the first station Thane, and remaining is the cut and fill. Basically, it is mostly on the viaduct. As I said, there are 12 stations, 8 are in the state of Gujarat and 4 in the state of Maharashtra, and all stations are elevated except Mumbai, which is underground. And limited stop trains, there is a running time is 2 hours up to Sabarmati. Ahmedabad is slightly less than Mumbai. Ahmedabad is 1 hour 58 minutes. And all stoppage train, it takes 2 hours 58 minutes. The cost of the project estimated in 2015 is 1,08,000 crore in Indian terms. Roughly it comes to $30 million per kilometer. That was the estimated in 2015. And we have adopted the standard gauge 1435 mm, and design speed is 350 kmph, operating speed is 320 kmph. That E5 Shinkansen technology we are going to adopt. Train configuration, we are having 10 car set, and we'll be having 24 rakes initially. And we have planned per day per direction trips 35 initially. And we have roughly train capacity per rake is 750. As I said, there are 10 car train. So roughly 75% passenger per car, you can say. And per day direction traffic is unidirection 17,900. And we have planned, we'll keep 3 trains peak hour, 1 direction, and off peak, it will be 2. Basically, operation control center will be at Sabarmati. Maintenance, there will be 2 maintenance depot. One will be at Thane, another will be at Sabarmati. Sabarmati will be a major depot. Thane mostly for minor schedules and stabling purpose. Thane is near to the Bombay side, and Sabarmati is the last towards Ahmedabad. As I said, light maintenance will be done at Thane and Sabarmati, but heavy maintenance will be done at Sabarmati, and that is a workshop also. So power supply, will be having a 12 traction substation, 2 depot substation, and 16 distribution system. OHE, we had adopted 2x25 heavy compound catenary, same everything, same Japanese OHE. Signaling DSATC, digital ATC, similar to Shinkansen. And we have fitted with disaster prevention system for the safe operation. And state of the high-speed railway training institute at Baroda has been already constructed. This is the first thing we did it, because high speed, we have not run any high speed. So for gathering the knowledge, even for the construction of the high speed, we require a training, many training. Some person will go to Japan, and it will be done at Baroda. We expect our annual energy requirement will be 1100 million unit. That is inclusive of traction, non-traction, train, station, everything. As I said, it is the E5 system. It will be maximum running speed will be 320 kmph, and it will attain that in 310 seconds, covering a distance of 18 kilometer. Braking, normal braking is 167 seconds from 320 to 0. Distance travel will be 8.5. However, power failure detection brake, in case this is emergency braking, then in 78 seconds, train will come to halt. This power failure will triggered when there is some earthquake type of thing. Otherwise, normally service brake will be applied. We have 3 types of coaches: standard, business, and first class. We call it grand class. Fare will be our Indian system AC first, whatever is train running Rajdhani will be 1.5 times of that comes around 3,000 rupees. Other fare for other classes we have not decided. This is the base class fare. It will be roughly, you can say, $40 in terms of dollar. Key technologies, we have tunnel boom effect, we have to control. We have got as Shinkansen, train nose and tunnel hood provision is there. We have a pressurized car body, double skin hollow aluminum car body. Noise mitigation measures are there in the total rack. Pantograph, special pantograph. Reduce air drag, nose and other things. And special luge control system, so that jerk should not be there for the traveling passenger. Driver support system, directly from the OCC, control can interact with the driver. Continuous automatic train control system, digital auto frequency track circuit, track to train transmission, because fallback system is also there. And this is a unique thing from Japan, gas pressure monitoring system in signaling system. So first, in case any problem in the cable, the first gas it will puncture the gas as soon as it will be detected. And then we can control the failure, because still cable is live. And then heavy duty point machine with swing nose. Electrical, I said, heavy compound overhead OHE system. Automatic switch neutral section. We have been provided with the disaster management system. Project status. Survey we have completed. This is we have adopted LIDAR, that is light detection and ranging. This was first time adopted in a railway project, and it has within 3 months we could do it. And there was another in hydrological survey, because as I said, it is passing through the creek under the sea. So we have gone for this one. And then we have also finalized all the manual standard alignment and GAD. There are 59 GADs crossing over the railways, national highways, river, everything is finalized. This is a LIDAR system. It is mounted on the helicopter with GPS system. And this is the ortho photo, we got it, all 3-dimensional photos. A very accurate survey. And this project is totally a greenfield project. So we have done from the Mumbai to Ahmedabad with LIDAR. Viaduct, we have adopted viaduct. But as you know, India is a very heavy populations are there. Population density is there. So just to reduce the land acquisition, we have gone for the viaduct. And it is only a 17.5 meter width of the land we are acquiring along the project. And this viaduct, out of which width of the viaduct is 12.5 meter, and 4 meter is kept for the movement of the vehicle by the side of the viaduct. Benefit is reduction in land requirement, improved safety and security, no obstruction to natural flow of water, crossing at all places provided, so there will not be any problem. Multi-mode integration scheme we have planned for all 12 stations. Brownfield stations are Sabarmati, Ahmedabad. With this, we are integrating with the existing transport, because Ahmedabad, Vadodara is the most congested station. And greenfield stations are Anand, Bharuch, Surat, remaining, 9 stations. So we are integrating with the existing road network. We have standard design. We have got most of the design done at pre-bid stage and included in the tender document. For civil structure, all the span 35 meter, 40 meter, 45 meter. This is all design is included. Based upon the comprehensive geotechnical investigation, standard design of foundation substructure also provided in addition to superstructure. This will obviously benefit the contractor. It will reduce their risk and contractual litigation, saving in design time during construction phase. Land acquisition, we have gone ahead. 60% of the land has already been occupied and remaining is under acquisition. We have planned this contract management in 27 package, out of which 25 is construction package, 2 is consultancy. 3 tenders already awarded, 2 package completed. That is a hostel and training school. That's what I mentioned. Our first priority is training school. It should be made functional because we intend to train our contractors also, contract workers of the contractor for this design, so that they can adopt the high-speed design of Japanese. In fact, some of the contractors will also be deputed to Tokyo for the training purpose. We have invited all the 9 packages, major packages, but somehow it was to be open in March, then it has to be postponed, and it is getting postponed because of this pandemic situation. So latest, it has to be opened now in August. Let us see whether it gets opened or not, or we have to shift again. Benefit, there are huge benefit. This, we are getting a state-of-art technology. So in our railway sector, there will be a technological upgradation. Some make in India, some of the things are being will be manufactured in India. There is a tie-up with the Japanese industries. Skill upgradation, this high speed, as I said, roughly 3,000 officials will be trained in high speed technology during the project. This skilled manpower will be the backbone for the future project. Speeding of India into journey into future. India, as you know, is the developing country. So there will be for everybody, for speed, is modern, all-weather, reliable, safe, eco-friendly system will be there. This will bring a economic growth with development of small 2-tier and 3-tier cities. Self-sufficiency in energy will reduce dependence on imported energy. There will be less, carbon footprint will be less. This will provide employment and development. Boost to industry, creation and construction of high-speed network is a heavy investment infrastructure sector. And it is said, this is experience, the high-speed rail project has a direct correlation with a rise in GDP. For each 1% increase in market access, there is 0.25% rise in GDP. Cement and steel, this is the major constituent, and estimated quantity for the concrete will be 12 million meter cube, and such huge requirement of concrete translate into cement requirement of 5.5 metric ton. That is, 2 million tons of cement will be annually required for the 3 years. Same thing is steel, 0.5 million ton will be required for the 3 years annually. This new high-speed network will create obviously strong and steady domestic market for rail and transit. Employment generation, not only the direct for the maintenance and operation, there will be at least 20,000 employment for the construction worker, and they will be equipped. They can deal with after dealing with the first project, we have also planned for the future projects. I'll discuss later. Urban development, tier 2 and tier 3 cities. At present, Bombay and Ahmedabad, Surat, these are the developed city, but other Vapi, Boisar, they will also, and this will also decongest the major city like Bombay. This will be win-win for the local government. Their properties, obviously value of the property will increase to property tax. Landowner are getting a good deal. Although in the station and above station front, all the facility development is also planned. Ease of travel will be there. Direct connectivity to central business district. Speedy services, 2 hours between Mumbai, Sabarmati, as compared to 8 hours presently by a conventional train. This is a huge, train journey will be converted to commuting basically. It will not be termed as travel, it will be commuting. Reliability, as we have taken from the Shinkansen, Japanese technology, reliability, safety is well proven. this increase in high speed, faster trip, higher ridership, and this will reduce the load on the, basically, we anticipate there will be a direct transfer of traffic from the air. Has been considered from the carbon footprint point of view. It is a very, it is almost 170 gram per passenger from the carbon it generates, whereas a high speed train generate only 8 gram per passenger. This after commissioning the project, daily users are expected to be 40,000 person per day ridership, which will increase to 156,000. Initially 10 car rake to 750 passenger. Later on, it will be increased to 16 car rake. So we can cater per rake 1250 passenger. This will be equivalent to carrying a 8 low-class airplane. Safety, as I said, the Shinkansen technology we have adopted. They have a record of more than 50 years of experience, and they have a record of 0 passenger fatalities. So the total system is coming from the Japan. Signaling, rolling stock, electrical, fuel and energy, there will be saving. Environmental benefit is there. Carbon emission will get drastically reduced on account of travel. But we have challenges also. Challenges of construction of long elevated corridor, construction of undersea tunnel, working in 3 brownfield area, working in the busy railway area, creating a pool of skilled manpower. As I said, our 90% alignment is viaduct. So we have gone for the full span launching method of, this is the full span to expedite the construction work. Undersea tunnel, 21 kilometer tunnel having a dia of 12.1 meter. It has been planned, undersea tunnel, to basically to avoid disturbance to flamingo sanctuary and nearby mangroves. That is why we have gone undersea. Construction methodology by TBM and NATM. Working in the busy rail area, this is also a challenge because at some location alignment runs very close to the existing track, no space for the accommodating pile cap or spread footing. Shinjo pile, they have suggested, Japanese consultants suggested Shinjo pile technology. It does not dig big pile driver machine. Shinjo pile method used in Japan, although it is not common in India. This is a method. With this method, we can work very closely to existing track. Skilled manpower, this is required. That is why we have gone for the High Speed Rail Training Institute at Baroda. And this will be functioned, although construction work is over, this will be fully functioned in 2021. This is the basic thing. This is the first thing we have gone for. This is a building. Already construction part is over. What does the future hold? This is the, we are going for a long way. 7 new corridors have been identified for which DPR, we are writing we have been given the responsibility of writing the DPR. These are the corridors. Delhi Varanasi 865 kilometer, Mumbai Nagpur 753 kilometer, Delhi Ahmedabad, Chennai Mysore, Delhi Amritsar, Mumbai Hyderabad, and 7th one is recently announced, Varanasi Howrah. So we are preparing the DPR of this, all the 7 corridors apart from the existing high speed Mumbai Ahmedabad. So thank you.
Sandeep, thank you very much. What an exciting project. Really impressive what you've undertaken. And as I mentioned in the beginning about this not being just a transportation solution, but a transformation solution,
Yes.
you really hit on that, and I really appreciate that. And it's going to definitely transform India, as we've seen also as the metro, Delhi Metro. Everyone said that was too expensive, it could never be done. You know, why are we trying to do this? But look what happened with the metro. Now it's spreading to every metro area, and the same thing's going to happen with high-speed rail in India. And my hat off to you and your whole organization for undertaking this incredible project. So now we're going to move to California high-speed rail, and our presenter, Bruce Armistead, is not able to join us. So he's giving us a virtual, previously taped presentation, and we're looking forward to hearing from him about California. So I'll turn it over to Tony and we'll take a look at this. Maybe not. So
Just one
wonder-
one moment, we're ready to go.
okay, here we go.
Good afternoon. My name is Bruce Armstead. I'm Director of Operations and Maintenance for the California High-Speed Rail Authority, and I'm honored to be presenting an update on our project in California. The California High-Speed Rail Project will increase mobility. It's a needed alternative to runways and airport gates. It will result in better air quality and job growth. The diagram to your right shows phase 1, phase 2, and stations of our project. High-speed rail, it's happening. We are currently under construction for 119 miles between Merced and just north of Bakersfield at approximately $4.8 billion investment. Targeting the Central Valley, we have 3 construction packages within the Central Valley. CP1, which is shown there as TPZP, CP23, Dragados Flatiron, CP4 is California Rail Builders. They comprise 30 active construction sites, and we have about 4,000 construction workers employed. The environmental clearance is advancing. We've locally generated alternatives, which was complete in October of 2019, 30 months ahead of our deadline. The Central Valley Y in September, Bakersfield to Palmdale, so on and so forth. The Los Angeles to Anaheim section and the Palmdale to Burbank section are upcoming to be completed. Southern California, we're investing in all regions of California. And in Southern California, we have a $1.3 billion investment. That includes $441 million for the Los Angeles Union Station, $363 million in environmental review work for high-speed rail, Metro Lake, which is the regional rail service in Southern California, LoSAN, which is the intercity rail service in Southern California, and we have a $77 million investment in the Rosecrans Marquardt grade separation. The graphic of that is shown to your right. And we have an additional $389 million in Prop 1A funds for what we call connectivity projects. These projects are intended to connect to high-speed rail. Northern California and in the Bay Area, we have a $1.6 billion investment, 714 of which is for the Caltrain electrification project. We're electrifying the railroad in Northern California from San Francisco to San Jose. 293 million of that is on environmental work between San Jose Merced and San Francisco to San Jose. 84 million of that is being spent on the San Mateo grade separation project, which is currently under construction. And we have an additional 543 million in Proposition 1A connectivity projects. 2020 status. This is an overview of the status of our project throughout the state. In the middle, as we talked about, Merced to Bakersfield is currently under construction, 119 million of which you'll see is under active construction, and the other pieces are in project development. To the left on the slide is the 51 miles of electrification of an existing railroad that's currently being undertaken by Caltrain, and that's from San Francisco to San Jose, as I mentioned earlier. The dotted line going from San Jose into what we call the Central Valley Y is currently under environmental review. Similarly, the portion from Bakersfield down to Palmdale and on to Burbank and Los Angeles, down to Anaheim in the bottom of your screen is also under environmental review. The heavier lines are cleared for project development, and the yellow and green dots show major station funding. To the right is the Victorville to Las Vegas Victorville to Las Vegas electric line that's being installed by Virgin Trains. 2022, we expect to have the San Jose to what we call the Central Valley Y completed and cleared for project development. We also expect to have the Bakersfield, Palmdale, Burbank, Los Angeles, and Anaheim section cleared for project development. And we expect to be under construction in all the 171 miles from Merced to Bakersfield. So in summary, we will have the full phase 1 system environmentally cleared and 350 miles of that under construction. And now we're going to look at a brief video of the high-speed rail project, which will show some of the current progress in the Central Valley.
Well, we're making history. We're making history for the future.
In a year no one will forget, in the middle of a historic pandemic, thousands of construction workers,
and it's not just men, it's women and youngsters, old guys like me,
are making history of their own.
Makes me feel proud because this will probably go in the history books, and my children and my grandchildren could see back and see what I was participating in.
Continuing to build California's high-speed rail. Despite the worldwide COVID-19 pandemic, despite a quarantine slowdown that's affected all of us, California's high-speed rail program continues to move forward.
We're providing stability for families, stable work, stable paycheck, stable family.
32 active construction sites dot the 119 miles of construction from north of Madera to south of Corcoran. To complete that work, more than 4,000 construction jobs have been created, with around 1,000 workers being dispatched to the job sites each week.
We have, over the course of the last year, increased the number of workers out on our construction sites by fourfold.
And of those workers, 73% call the Central Valley home.
Close to home, for sure. I'm 30 minutes from home as opposed to 5-6 hours from home.
In Construction Package 1, stretching from Madera to Fresno, rebuilding State Route 180 over the Fresno Trench is underway, transitioning to Stage 5 of that project. Signature structures like the San Joaquin River Viaduct and the Cedar Viaduct crossing over State Route 99 are closing in on completion, as are a number of new Madera County bridges at Avenue 15, Avenue 10, and Avenue 7, where in early July, Avazon Construction, one of 183 disadvantaged enterprise businesses, was working on the project laying asphalt. In Construction Package 2-3, the amount of work there has exploded. Bridges and overcrossings, utility relocation, and even canal construction span the alignment. At the Melga Canal, 200 cubic yards of concrete poured for just this section. This work is being done in preparation for the future Jackson Avenue overcrossing nearby. While crews have begun pile driving the more than 7,000 piles that will be required to build the Hanford Viaduct that will eventually allow high-speed trains to pass over State Route 198. Preparing for a milestone at the largest project in Construction Package 4. Crews at the Wasco Viaduct are constructing the side of the pergola there that will eventually hold more than 70 giant concrete girders, helping high-speed trains pass over the existing freight line. 2020 and COVID-19 have left California and the nation in uncertain times. But at times of the greatest need, the nation has historically turned to infrastructure projects, from the New Deal to the American Recovery and Reinvestment Act. And as we forge ahead, High-speed rail will be there continuing to build and rebuild for our state.
The best thing that this project has going is what we are doing for economic development in the Central Valley. It's the stability for families at a very unstable time.
As you've seen, we're very, very excited about high-speed train and the construction work that's going on in the Central Valley and the work we're doing to encourage investment in the Central Valley, to move the economy, and to create jobs. And to that end, we will be meeting our Federal Railroad Administration and ARRA, American Recovery and Reinvestment Act, obligations. And those deadlines are shown on this slide. We have to align Central Valley segment, 119 miles between Madera and Poplar. We've aligned that with our 2019 update to our baseline. And at the May 2019 board meeting, the budget was approved for that baseline. Upcoming procurements include our track and systems contract. That scope includes design, construction, and 30 years of maintenance for certain pieces of our infrastructure. Specifically, track and switches will have ATC, which is automatic train control, which includes the functionality of positive train control. We'll have a communication system that includes earthquake detection. Stations and platforms will be in that contract. Well, the OCS systems, high voltage substations and switching stations. The OCC will be built under this contract and will, as I said earlier, have a 30-year maintenance responsibility, and our DBE goal will be 30% for that project. So essentially what this is intended to do is to put all the systems on top of the civil infrastructure. That project will be broken up into segments. Segment 1 will be the Central Valley segment, which is the segment that's currently under construction in the Central Valley. The civil works that you saw in the previous video show the civil works that we will be using to install these systems on top of. And that also meets our grant requirements of the 119 miles that has to be in service. Segment 2 is Poplar to Bakersfield, and that's 20 miles. Segment 3 is Madera to Merced, which is about 30 miles. And then Gilroy to the Central Valley Y is about 96 miles. And lastly, segment 5 is San Jose to Gilroy, which is another 30 miles. All these will be individual notices to proceed, as I said earlier, and we will manage the contract in a way that will issue these notices to proceed as the civil works is completed in those areas. Procurement is for the entire Valley to Valley segment. What we call the Silicon Valley to the Central Valley is our Valley to Valley segment. Bakersfield, Merced to San Francisco. But as I mentioned earlier, there's only one authorization to proceed currently anticipated, and that's the Madera to Poplar section, the 119 miles. And we expect that to cost about $1.6 billion. And each notice to proceed will have its own board approval. The RFP, we released the RFP to the shortlisted firms in December of 2019. The industry forum was held on January of 2020. Proposals were due on October 20th, 2020. And our staff recommendation to the board will happen in January of 2021. Shortly thereafter, we expect to issue notice to proceed in January of 2021. That's my presentation, and I look forward to your questions and really wish I could be there with you all, as even virtually, it's very difficult for us in California. But again, I look forward to your questions and hope to be hearing from you soon. Thank you.
Thank you for that presentation. And I want to encourage everyone, as he mentioned, to submit their questions here. And he's promised that he'll answer them in writing and get the information back to us. So I think that's really great. One of the things I took away from that session was his use of the word investment and the focus on jobs. So it was a very good presentation, not only for the substance and updated progress, but I thought it was an excellent presentation from the standpoint of how to sell a project to politicians and to the public. And I learned a lot from watching that presentation. Next, we're going to have Rick Harnish. And I've known Rick for some time. Rick is a great guy, and he's been trying to do almost the impossible, which is persuade Americans that we need high-speed rail. And I think most of the people on the East and West Coast believe him, but he's based in Chicago, in the middle of the Midwest, and he's trying to convert people that don't really see the value of it, but he's making progress. He's making substantial progress. And I think with the success of what's going to be happening in California and hopefully what will be happening in Texas, he'll have a good story to tell that will attract other people to high-speed rail. And so Rick, I turn it over to you. I know it's early in the morning where you are, and I appreciate you making time for us.
It's my pleasure. Thank you very much for having me. Am I on?
You are.
Excellent. So thank you for that wonderful introduction. We are making progress. And you know, as you mentioned, Midwesterners are incredibly conservative. And we've certainly, with the recent challenges, we're going to have a challenging time. But I wanted to share quickly about our philosophy. So we are a nonprofit. We are supported mostly by individuals who just themselves want to be able to take the train, or they want their communities to have the benefits that happen when people can connect to their communities by train. So this really is a ground up operation to persuade Congress and the states to invest heavily in high-speed rail. There's a couple of things that, you know, in these challenges, we said, are these things still relevant? And the first is, yes, travel is absolutely always going to be important. This is an ad from when they opened the high-speed line in Taiwan. And on the left is the grandparents' house on the weekend before high-speed rail, and the grandparents' house on the weekend after high-speed rail. So there are things that you simply cannot do over video, and that's always going to be to make travel very important. And our second premise is that trains are a great way to travel. They're very affordable for traveling, and it makes it possible for a lot more people to travel a lot more productively than they can by automobile. And I recognize that Germany has a slightly unique level of service since their high-speed trains are not quite as fast as others, but this kind of represents all of the different things you can do while taking a train, work or relax, or even drink a lot more than you can while you're driving, if you look at those guys in the lower right-hand corner. So this would bring huge benefits to the country. The challenge is persuading us as a nation, again, to do something that's very new. We haven't really accepted the fact yet that this is something that's not new, but it's new to the Americans. So in order to make this a reality, there's three things that need to happen at the federal level. There's other things that need to happen at the state level, but the three kind of core things at the federal level is we need a commitment of at least $10 billion or more, not just for high-speed rail, but for the connecting services. And the California speaker talked about how they've got a piece of their budget is actually going to connecting services. We've got a decent framework in terms of the policy and the structures for building high-speed rail. Some tweaks need to happen to some loan programs and to others. But if we had the money today, then we certainly have the programs. So we need to get those reauthorized and improved. And then the last is, because we see this as a very connected network where high-speed passengers will at a station or perhaps on the same train connect to services that are on heavy haul railroads. One of the things that's very broken in this country is the relationship between the owners of the railroad tracks and the operators of the passenger trains. And we're going to need to tackle that and find some way to make the Class 1 railroads see this as a profitable business. The same way that defense contractors see selling things to the federal government as a profitable business. But in order to do that, to do these three things, we're going to need to unite a very large group of people, spread out over a lot of different types of territories in very different congressional districts. And frequently, because transportation in this country is largely a rural matter with big highways out in the country, the heads of the transportation committees, the most powerful people, are typically rurally motivated. And so what we need to do is figure out how high-speed rail between major cities also impacts a much larger area in order to create the political will to make that $10 billion a year minimum happen. So we came up with a way of explaining this. So in most countries, you already have a good basis of conventional railroad service, and high-speed rail is added to that conventional service. We don't have that in the States. So we came up with a way of explaining how different pieces can work together in order to make this a very functional system. With three types of track. One, high-speed lines. You know, in this country, there's a break point of 125 miles an hour. Certainly, we want long stretches of 200 miles an hour. Getting into urban areas can be very challenging. So we've come up with a way of describing a way of rebuilding existing lines within urban areas to create a new type of commuter rail service we don't have today, and high-speed rail in big urban areas. And then these shared use lines with heavy haul trains. And we need to think about this in order to create that political coalition. We need to think about this as a unified system or an integrated network. So if you're a company wanting to get something started, you need to focus on the minimal viable segment. But if you want to get political support, you have to think about very broad impacts. And it's very difficult to unite those two very different needs in order to make this work. So this is kind of explaining to folks, because most folks only care about the place they're starting from and the place they're going. So we created this conceptual network to explain this is how planning works in the United States right now. Each little segment is planned individually, and you never really get to the point where you can make a lot of those segments work. But we believe if you took this network and instead of doing it individually, did it as a unit, then all of a sudden you've got a lot more volume for that high-speed line. You've got a lot more political support for it, but also more importantly, in this case, the Leicester to Johnsville, maybe that's a very frequent bus. Today, there's no connection whatsoever, but in this network scheme, that's a very frequent bus. And say the Harrington to Townsend becomes a high frequency mixed use line, but now you've got political support to build the high speed line in the middle. That's our basic philosophy. And at these transfer points, you make the stations very easy for people to get from one train to another. So where does this make sense? We don't really know because nobody's really studied it well. We think again in this mix of different things, different ways for each segment. We need to think about an integrated national network. It might look something like this if you really wanted to get full political support, a huge step away from the way we've typically thought about high-speed rail in this country. The yellow is a place where somebody has demonstrated that there's enough volume to build a new high-speed line. Either at the FRA level, they're doing some network planning in the South and in the Midwest. They also did that in the Southwest. The state of Washington is driving a Portland to Vancouver high-speed line. So that's the yellow. And there's a couple of missing pieces because nobody's taken the big picture approach yet, but that's there. So there is demand. You've got the Northeast Corridor, which is also running a very interesting and unique railroad with 160-mile-an-hour trains mixing with heavy haul trains, very difficult to operate. This map is too small to scale to point out that there's a maglev project under development between Baltimore and Washington, already in financial review. And then over there, we just heard about California, and then Texas Central is getting very close to being able to finance and break ground on that line. Hopefully shortly they will have their environmental approvals and then approval to operate from the Surface Transportation Board, which is the economic regulator of railroads. So we've got opportunities, we've got progress. We believe that getting one of these operating as quickly as possible, even if it's that short segment in the Central Valley, where Americans can fly someplace in America and ride an American high-speed train, and our insular culture will go, oh, now I get it. So we are making progress. I want to talk a little bit bigger about California. So there in purple is that segment that they would like to have as the initial operating segment. And if you're from San Francisco or Los Angeles, you think nobody lives there, but they're actually fairly decent sized cities. And then there's a little piece that's actually under construction, and they would like to make the initial operating segment that purple. The other solid colors are different pieces that are under development in one way or another. And then the gray lines are existing passenger operations that are on shared use lines, except for the Bakersfield to Burbank piece, which is a bus. So this is bigger than just LA to San Francisco. And so we wanted to point this out in terms of what happens to the network. Today, there are 6 trains a day between Merced and Bakersfield. It takes 3 hours. When the high-speed line is built, there will be 18 trains a day on that segment, and it'll take an hour and a half. But what that means is that somebody going from Merced to Los Angeles, and there's a lot of that traffic, will have an hour and a half taken out of their schedule. And today at Bakersfield, there are 75% of people connect between Amtrak and a bus. So there's certainly a market there. And then all of these connecting bus lines and these train lines go from 6 trains a day or 6 buses a day up to 18 trains a day or 18 buses a day. So it becomes much more robust. And there's also a commuter line that's being built today between Merced and Stockton. So this does become a very transformative piece if you look at it in terms of the bigger picture that California has. And this will make a dramatic change in the finances of the California system. So today that network to what they think if they don't do it versus with high-speed rail, ridership doubles, revenue more than doubles, and importantly, the cost of running that system per year actually declines. So getting this message out about this is a very statewide benefit is part of what we are attempting to do, and also explain in the Midwest why this is so critical that we start planning the same thing here and start actually developing it. So there's 3 chances right now to make a difference. Right now they're talking about the next round of stimulus relief. There's an urgent need to keep our Amtrak and transit systems, the base of the network, funded and running. That's being debated right now. The reauthorization of the transportation program, the current program will expire at the end of this fiscal year in September. It'll probably be extended, but the debate over that is happening now. And then the other big thing being debated right now is how much money we'll spend on railroads and other transportation in 2021. So there's these three things happening together that we have to be able to talk to people about in a simplified and motivated way. So again, we are a collection of people who want trains, not necessarily the vendors that will build it. But our first thing is to persuade people to come on board and become part of our network, and also to demonstrate a growing base of support. So the first step in that journey is an online petition that we have where people can sign their name and say to Congress, it's time to build high-speed rail. And that also then signs them up for our action network so that they can continue to be involved as time moves on. So that's a very quick overview of what we're doing and what the opportunities are. I'd be happy to take any questions, Kirkland.
Audio, okay. Sorry, I was having trouble unmuting myself. Thank you for that overview, Rick. It's quite, I really commend you for the way you've thought this through. You know, coming from a Japanese perspective, we're trying to connect viable city pairs and travel at very high speeds with dedicated line service. But I think that most of the country would not be able to achieve that. And the things that you're suggesting are very a good way to approach and gain support in a lot of the areas that you have. I would like to begin by asking generally, what are the things, John, I want to ask you, John, this first, but what are the things that you've learned in doing your project that you think would be the most important thing for everyone else to understand? And you did highlight in your presentation the cooperation between the manufacturers and the suppliers and the operators and your consultants and things, but you've had a remarkable success story. But what if you were going to build one again? What would be the areas that you would want to really pay attention to and promote? What do you think people need to hear about this as a lesson learned for others to take into consideration?
Okay, Toko, that according to Taiwan high-speed rail's experience, in the beginning, that when we started our projects, we trying to integrate a lot of sophisticated function. But if you look for the life cycle, I mean, cost of the one high-speed rail system, probably it's better to have, I mean, more simple system. Because if you look at the maintenance costs and for the future replacement costs, probably it's tremendous, especially in terms of high-speed rail maintenance. So if we can do it again, for example, for this project, we hope we can, like in Nokia, we decided at that time that we choose high-speed turnout, for example, and which make us a tremendous problem because it's too complicated. So that means high-speed turnout means it's a huge turnout. For example, we have around the maximum number is just nine switch to move this turnout. So any one of these 9 switch is out of order, then the whole set of turnout is out of order. So for example, for this kind of, we are too ambitious at the beginning, so that we actually, that I think the simple is the best. So this is, I think at the beginning that if you have time to redo it again. And other than that, of course, you need, I mean, to have a viable high-speed rail. You have a very good corridor. It's a sustainable, I mean, corridor which can, I mean, always have ridership increasing, so that can make the operator, you can be a survivor for all the time. So, but in this part, Taiwan is okay because we choose the west part of Taiwan Island. This corridor is very congested area zone, including the 3 main big cities. So it's good. But I think this is one experience for any one of you. You are ready to, you are planning to have a new high-speed rail system. You have to think about for the future. To construct, to build a system is easy, but to make the life cycle cost can be balanced with our income. It's also very important as well. I think that the Toko I can give this experience to all of you. Thank you. Okay.
Thank you. Yes, thank you very much. I appreciate that. We have a couple questions for Sandeep. And one of these questions, what is the fallback system for train tracking? And what is the plan for train health monitoring? What technology is used for fixing the rails to the track slab?
Actually, we have a AFTC system, audio frequency track circuit system. Because it is a track circuit, health of the track is automatically monitored. And from this AFTC, all the movement authority is transmitted to the main cab, to the driver. And fallback system is the communication. We have laid throughout, we have planned to lay leaky coaxial cable. So fallback system is the communication base. And regarding this, your third question is track slab, how the rail fixing is done. I think I'll immediately I cannot answer. I'm not a civil engineer, look after the track portion. So I have to check up. I'll come back to you.
Okay, thank you. And I'm sure that that Craig will be able to get it to the questioners. A question for you has come in, Rick. And the question is about the political support for high-speed rail. It's been missing in the US in the past. And how do you see the impact of COVID moving forward this support? And what do you see any change in support as we through the election, either in the second Trump Biden administration? Do you see any different approach to give the political support for high-speed rail?
Well, so with am I on again, or yes?
Yeah.
So with in terms of COVID, Americans have a default to automobiles, and it was kind of disturbing recently to see a picture of a church service being held with everybody in their cars. I would have preferred to have seen them sitting in chairs in the parking lot but spread apart. So there is a little concern in the short term about how do we get through the hump. But we have noticed that throughout the country, wherever you are, there is strong support for trains to that community. And there's certainly strong support for like in Indianapolis getting to Chicago. Our challenge has been creating a message and a program that helps motivate all of these people and connect them together. I think it's possible. And I think certainly with the economic challenges that we're heading into, trains become much more important, and keeping all these towns becomes much more important. So I think it's a very different climate we're heading into, and change means opportunity.
Thank you, Rick. I appreciate that. You mentioned in your presentation about a Hyperloop test track, and those people that have been working with in Japan on the maglev system that has demonstrated it can travel at 312 miles per hour and carry passengers on it. I think you've ridden it and John Chen's ridden it. They know the technology can work, it can go fast. I wonder if each of you would like to comment on what you think about the opportunity or the challenges of Hyperloop in your countries, and whether you think it's a viable alternative in the 10-year or 20-year future. And so Rick, I'll let you start, and then I'll ask each of the other of you that question.
Well, first of all, I want to point out that the business communities in Kansas City, St. Louis, Cleveland, and Toledo are the ones who have financed those Hyperloop studies, and Columbus as well. That shows me that there is demand for a very different travel mode than what we have. And that gives me a lot of hope. I'm concerned because there are lots of promises about what Hyperloop can do that sound a lot like what railroads probably could do better, other than the speed, but the speed at this point is theoretical. And we really need to focus on how we can create a product that works as quickly as possible.
Thank you. And John?
Okay, I just unmute.
Yeah.
Yes, sorry? Yeah.
Yeah.
Okay.
Go ahead.
So you mentioned about the Hyperloop, right?
Yeah.
Okay. I have seen that outside, as fast as I concerned, I know that because Hyperloop looks as because the speed height in but you see to operate the system, you have to think about it. From time to time, there's a breakdown. For example, that the train breakdown in intermediate station. You have to evacuate the passenger. That with this kind of Hyperloop, how can you evacuate the passengers? So it's not easy. So it's actually I cannot. It's not easy to conceive that what kind of when there is this kind of situation, how an operator can cope with this kind of evacuation case. For example, this is in the beginning I can think about it.
I see. Is there any effort to try to build a Hyperloop in Taiwan?
No. At this moment, no, it's not possible. I don't think. Yeah. Yeah. You see that we think high-speed trains is maybe because that our performance is quite good, quite outstanding actually. So the older city, like in some other city which they don't have a high-speed train project through their city, they are trying their best so that they can get the central government support to have a budget so that the high-speed train, the Taiwan high-speed rail can extend to their city. So
Yes.
at this time, they don't think any other transportation means.
Yes. I've noticed in some countries, I think in the Netherlands, they're looking at, there's a team looking at a freight use of Hyperloop, carrying a freight pod. Because of course, you don't have to worry about G's and you don't have to worry about personnel safety for high value perishable product that needs to be moved by speed. Sandeep, what about in India? I heard that there is some Hyperloop activity, no?
No, at present there's nothing.
No.
I don't think, no, nothing.
Okay. If I could ask Sandeep another question to you, this one not technical, but in India you have those proposed ideas for new high-speed rail efforts. And I know a lot of people are concerned about the cost, but how do you explained it very well in your explanation about the benefits that would be perceived. How does the public react to that, and what are the tools that you think or that can be applicable, the ideas that can be applicable to the rest of us for persuading the public about this? Because India is a very democratic country and it's very difficult. You can't just evict somebody from their land. Everybody has to be on board, pardon the pun, to move these projects forward. So do you have any advice or recommendations about that for us?
Only publicity, so far as land acquisition is concerned, so there is a consent. We have gone only for the consent. We have convinced all the landowners this is the advantage, and this way they can they can improve their area, their nearby. So it is always through the consent method. It is no forcible land. Although we are a government entity, we can have that option. But still, till date, we have acquired almost 65% of the land. It is only purely on the consent. This is one. Number two, many publicity. Yes, there are opposition. This is a very high value thing. Why high speed is required? But we have we could sail through because advantages we have shown on in terms of the environmental benefit, lesser carbon footprint. So people are becoming aware, and we have also time for a 500 to 800 kilometer of distance. You can 500 you can travel in 2 hours. For any aeroplane, time is the essence nowadays. Aeroplane, I mean airport is always far away from the city, main city. High-speed train can start from the main city through the tunnel, etc. It can move. So from center to center, you can reach within 2 hours. Whereas for any distance, you have to go 1 hour traveling time reaching to airport. Pre-departure is 1 hour. 1 hour is the flying time, and again coming back to the center of the town. 4 hours is the minimum for any air travel, whatever is the distance. So high speed has the advantage. I mean, in terms of the time, in terms of the environmental issues, because India is signatory of the Paris climate. So we have to honor these things. So we are going, initially this is the first, actually in metro also, the first metro always took time. After the first metro, you see in India, in every city, metro is coming because public has seen the benefit. Because initially we are very densely populated. Whenever any metro or this type of system comes, so there are inconvenience.
Yes.
So once they see, then they are convinced. Like metro, everybody is convinced that metro has to be there. You will find in too many Indian cities. I mean, A-class city, now it is extended to B-class city also. The same thing is going to happen. This is the initial resistance, nothing more.
Yeah. Yes, well, thank you. Really, I think you really nailed it there. We have a question that's been put up here about, of course, safety is paramount, especially going at such high speed. And there have been accidents with high-speed trains in some countries, and definitely when there's mixed use on the tracks. But Sandeep, your train's going to be traveling very fast, and John, your train travels very fast. How do you ensure your perfect safety record? Let me start with you, John. How do you ensure that? How do you achieve that perfect safety record that you have? How do you achieve that? You're on mute still.
Oh, sorry. So it's on mute now. We in Taiwan high-speed rail, we have a very robust safety management system. So actually, there's one slogan all our one-line staff know that without the safety, no safety, then no high-speed rail. And we try our best to encourage our staff, say that don't always focus on the on-time performance, but we also have to think about the safety. And also because we have in our procedure, we from time to time now we ask that our staff to review the safety, especially the safety in terms of safety. So also that, for example, we have a job description for each staff, especially for the online staff. So in our job description, there's always one paragraph say the safety, safety awareness in this job description, so that we ask that all staff, you have to always think about the safety. So I think that you have a very good safety management system, firstly, so that you keep on reminding that your staff, especially for the front staff, you have to know that the safety. Also the training, the periodic training, like refresh training every year. Always you put one of the agenda in this training session. That's of course the safety. So we doing this part from training and from the our procedure, that we trying to have a very robust safety management system. That I think that's several things that we are doing so that we can keep our safety, system a very good safety performance record. Okay.
Thank you. And I guess you also have a dedicated line, so you have no level crossings, and you have automatic train control system that helps. And Sandeep, what about you? How are you going to keep a perfect safety record?
Government of India decided to go with the Shinkansen technology because of their safety record. And they are more than 50 years old. I think the first high bullet train was started in 1964 in Japan. Until date, there is no fatality. That is why we are taking the full lock, stock and barrel Shinkansen technology. Not only technology, we wanted to adopt the Shinkansen system of maintenance, system of running. That is why we said our first priority was of constructing a training school. This is the first building we got it, well, apart from the structure, because we want to train. First, the initial some person will be trained at Japan. Then Japanese will come here and they will train the even construction worker also. The quality, because as you increase the speed, obviously precision comes. Everything has to be very, very precise. All the tolerances, dimensions, etc. So that culture we intend to bring in, that Japanese culture, Shinkansen technology, not only technology, culture. We are trying to bring the culture. So hopefully everything will be all right, but it's too early.
Yeah, I'm sure you'll do very well. How about you, Rick? How do you view the safety approach to your high-speed rail efforts?
Well, you know, certainly on the high-speed lines, you've got the advantage of being completely grade separated and separated from freight tracks. And except for the one accident in China where the dispatchers overrode the signaling system, there haven't been any fatalities with high-speed trains on high-speed lines. And certainly we need a different safety culture here in the United States on the freight railroads. They accept what I think is an unacceptable level of accidents just as a matter of doing business.
Okay, well, thank you. Well, we've had a very good session. I'm gonna go around one more time, starting with you, Rick, and then Sandeep, and finishing with John, and ask you to just say whatever you'd like for about 1 minute. But before I do that, I just want to thank the audience for hanging in there. And if you have any further questions that you'd like to direct to any of us, please do send them in. And I'm sure that our organizers will make sure that we get those questions. We'll give you some written answers back. So I really appreciate that. And so let's wrap up. And Rick, can you give us a minute about what you'd like to make sure the audience takes home with them?
I think there's a huge opportunity in the States to get things started. And right now is the time that Congress is making some key decisions. So if people would like to be involved in helping persuade Congress to make the right decisions, please contact us at hsrail.org.
hsrail.org.
hsrail.org, right.
Very good. Very good. Sandeep? You're on mute.
Yeah, tell me.
Would you like to just make a final comment to the audience?
India is just going to start our Blue Train high-speed network. And we hope this is not the last. We'll be having many corridors. India is a big country. First corridor is the basic thing. Once we are experienced, then we'll be having many corridors, and we are bound to improve the environment through high speed, because everybody knows carbon footprint is very, very less in the high speed train as compared to aircraft, as compared to the automobile, another thing, a conventional train. So hopefully we'll be running first high speed first bullet train shortly in India.
Yeah. Very exciting. And John, you have the last word.
Okay. I think after accumulating 13 years of operation and maintenance, that we are glad if we have opportunity to share our experience with our colleagues. I mean, especially for the Japanese Shinkansen system. I think that it's a good chance for all of operators can share the experience, and also we are like to, if necessary, we can provide our experience to all our colleagues. That's all. Thank you.
All right. Thank you. And thank you, audience, for staying with us, and have a good rest of the program to you. Good day.